Hello, this is Mr. Stansbury. I'm going to take you through the 8G notes on problem solving with quadratics. Okay, at the end of this you should be able to say I can solve real world type problems by solving a quadratic equation. Okay, so first thing we're going to do is take a look at example 39 from page 263, and it says the sum of a number and its square is 42. Find the number. Okay, so the sum of a number and its square is 42. Find the number. So let's just assign some variables. Well, actually just variable. So x equals the number. Right? So the sum means addition. So we're going to add something together. The sum of a number. So x plus its square. So x squared stands for equals. So x plus x squared equals 42. So since we've got an x squared, an x, and a constant, I'm going to move everything to one side and try to factor it. Okay, so let's subtract 42 from both sides here. So over here on the right we'll end up with 0, and then I'm going to put my x squared term first, plus x minus 42. That just makes it a little bit nicer to try to factor. Okay, so since this here equals 0 and our leading coefficient is 1, I think the easiest way to do this is to just do the backwards technique where you start at the right and then work backwards. So what are the factors of 42 that have a difference of 1? Right, so 42. Factors of 42 are 1 and 42, 2 and 21. Let's see, 3 and what's that give us? 14. 4 doesn't work, 5 doesn't work, 6 works, right? 6 times 7, and those are all of our possible factors. So again, we want to say what are the factors of 42? Since that's negative, that means difference. Factors of 42 that have a difference of 1. So the factors here that have a difference of 1 are 6 and 7. So we go x and x, put the 6 in, put the 7 in, doesn't matter where. This sign here with the b term always goes with the larger of the two factors when you're doing the backwards technique here. So this is positive, and this negative here tells me that the signs are opposite. So since this is positive, this has to be negative. Okay, so again, we're not quite finished. We actually have to figure out what these equal. So x has to equal, and again, as long as this is equal to 0 or this is equal to 0, then we're okay, because 0 times anything gives us 0. So 6 minus 6 gives us 0, so x could be 6. Or x could be negative 7 plus 7 also gives us 0. So that number could be negative 7, or it could be 6. Okay? Because if you, let's just double check it really quick. 6 plus 6 squared, that's 36 plus 6 is 42, so that works. And then negative 7, and then negative 7 squared is 49. 49 minus 7 also gives us 42. So both of those numbers would possibly work. All right. All right. Second and last example is Pete here. Say hi to Pete. Pete has a rectangular head. The height of his head is 5 inches taller than it is wide. If the surface area of Pete's face is 84 inches squared, what are the dimensions of Pete's head? All right, so we want to try to figure out what Pete's head is. So again, it's 5 inches. His head is 5 inches taller than it is wide. So let's do this here. We'll call the width of his head to be x, and then the height of his head is going to be x plus 5, right? So if we bring that down here, oops. Try to redraw Pete's head. That is terrible, but you get the idea. That's x, and that's x plus 5. So the surface area is 84 inches squared, so then we know that x times x plus 5 has got to equal 84 inches squared, right? So let's see, we're going to end up, when we distribute this through, we're going to have an x squared, an x, and a constant. So let's distribute it move everything to one side and try to factor it like we just did on the last problem. All right, x times x times 5. So we get x times x is x squared plus 5x equals 84. All right, so let's move our 84 to the left side, and we get x squared plus 5x minus 84 equals 0. Okay, so let's see if we can get that to factor. So we want to come up with the factors of 84 that have a difference of 5. 1 times 84, 2 times, we're going to be here for a little bit, huh? 2 times 41. Ooh, 3 works. What is that going to be? 84 divided by 3. That's going to be 28. We can do 4 times 21. Let's see, what else can we do? 5 doesn't work. 6. Will 6 work? I think 6 will work. Because that is 6 times, let's see, 14. 7 times 12. Let's see, 8 doesn't work. 9 doesn't work. 10 won't work, and I think that's about all the factors we have. So we got to figure out which one of these sets of factors has a difference of 5, and there it is, 7 and 12. So we got x and x, 7 and 12. The sign says that they're going to be different. This positive is going to go with the bigger one here because it's in front of the b, so that always goes with the bigger of the two factors. And again, since that's negative, the signs are going to be opposite, so it's negative. So from there, we get x has to equal 7 or negative 12. Now, since we're talking about Pete's head here, I'm pretty sure Pete's head cannot be negative 12 inches wide. So that one is out. So Pete's head has to be 7 inches wide. Now, it does say what are the dimensions of Pete's head, so just 7 is not actually the answer. We got to actually come up with the height too. So the dimensions of his head are 7 inches wide by 12, because 7 plus 5 gives us 12, 12 inches tall. All right, it's rather unfortunate that Pete has such a square-ish head, but we'll go with it. Okay, so that's how you do that. If you have any questions, please ask. Thanks.